Hello everyone. In today's lecture, I'm going to show you how to solve integration problems having trigonometric functions by the method of substitution. Let's take an example. Integration from 0 to pi by 2 of sine cubed of y cos of y with respect to dy. Okay, so what shall we substitute? Shall we substitute sine y or shall we substitute cos y? Let us substitute cos y, okay, and see what happens. So u is equal to cos y. Now we will have differentiate this one, okay. Du by dy is equal to minus sine of y. Fine. So what is dy equal to? Dy is equal to minus du by sine y. Okay. Now let's substitute here. So what happens here? Integration. This is equal to integration of sine cubed y will be remain sine cubed y, sine cubed of y, and cos of y is being substituted. This is u, okay, and dy is minus du by sine of y, right? Okay, so here 1 sine y and this will cancel, so we will be left with sine square y. So ultimately it will become sine squared y u du and the minus sign, okay, and the minus sign. Now what happens with sine square y? Can we replace sine square y with in terms of u? Yes, as you all know, we have the fundamental identity in trigonometry, that is sine square x plus cos square x is equal to 1, right? So we can easily replace sine square y in terms of cos square x like this. So sine square y is 1 minus cos square y, and this is minus u and du. So this is equal to minus u, integration of minus u minus, now this is, sorry, minus u, 1 minus cos square y is u square, okay, into du. So this becomes a very simple expression, minus u plus u cubed and with respect to du. Now what happens? Now this was, we were integrating between the limits of 0 to pi by 2, the upper bound and the lower bound, 0 and pi by 2, when it was y. But now we have substituted u equal to cos y. So we also have to change the limits 0 and pi by 2. How can we change that? So when y is equal to 0, u is equal to cos of 0, which is, cos of 0 is 1. So when y is equal to pi by 2, u is equal to cos of pi by 2. What is cos of pi by 2? Cos of pi by 2 is 0. Okay. So now we can change the limits between the limits 1 to 0. 1 because when y is equal to 0, u is equal to 1. So we can change the upper and the lower limits in the expression. So now it becomes very clear. So we have, again, as we had done previously, integration of minus u is minus u squared by 2. And integration of u3 is u4 by 4. Between the limits of 0 and 1. So when this is 0, this is 0, this is 0. So first part of the expression remains 0. And this will be minus, and we'll replace u by 1. So this will be minus half plus 1/4. which is equal to minus of minus 1 by 4th, which is equal to 1 by 4. Okay, so this is how you solve problems in trigonometry. Now, can you solve by replacing u by sin y? Yes, you can. So let's solve the same problem by replacing u by sin y. So u is equal to sin y. Okay, so du will be equal to cos of y dy. Okay, or because du by dy will be cos of y. So dy will be equal to du by cos of y. Okay, now if y is equal to 0, we have replaced now u equal to sin y. So when y is equal to 0, what is u equal to? Sine of 0. Sine of 0. So it becomes 0. So when y is equal to pi by 2, u is equal to sine of pi by 2, which is equal to 1. So now we can replace this expression by between the limits 0 to 1, sine cubed y. Sine cubed y becomes u cubed. Okay, and dy becomes du by cos of y, and we have on the cos of y this one. So cos of y and cos of y will cancel. So we'll be left with integration between the limits of 0 to 1 u cubed du. Okay, so this is the same as writing, if you integrate u cubed, it is u4 by 4 between the limits of 0 to 1. So if you replace this by 1, it is 1/4 minus 0. So answer is 1/4. You get the same answer as this. So it depends upon how you substitute any one of the expressions. This seems to, in this case, this seems to be much more simple than by replacing sin y by u is much more simple than replacing cos y by u. Okay, so it depends upon the questions. So whichever way seems easy for you, you can go ahead and do it. Okay, let's solve another problem. Now in this one, we see x to the power 4, sine to the power x to the power 5 and dx. Here we find it's a combination of a algebraic expression and a trigonometric expression. Okay, still it's quite simple to substitute. What shall we substitute? We see that here we have x4 and here we have x to the power 5, and we know that if we differentiate x to the power 5, we'll be getting x to the power 4 in the expression, which can get cancelled off with x to the power 4. So let's substitute u equal to x to the power 5. This implies that du by dx is equal to 5x to the power 4. Okay, which implies dx is equal to du by x to the power 5. Okay, so let's substitute this expression now. Integration of x to the power 4 sine of x to the power 5 dx is equal to integration of x to the power 4, and sine of x to the power 5 becomes sine u. Okay, and dx is replaced by du by x to the power 5. So this 5 and this 5 gets cancelled off. So what are we left with? Integration of sine u du. And we do know that integration of sine of u is minus cos of u. And we add the constant of integration. So this will become cos u is replaced again by x to the power 5. And we have c. Okay. So let's take another problem. Okay. Integration of sine cubed x dx. It is usual to substitute u by cos x. Okay, in such where we have powers of sine to the power 3x to make the integration very simple. So here we have du by dx is equal to minus sine of x. Therefore, this implies that dx is equal to minus du by sine of So dx is equal to minus du by sine of x. Okay, let's replace everything here. So instead of sine cubed x, we can have here, let's see, sine cubed of x, and we are replacing dx by du by sine of x. Du by sine of x with the minus sign. This sine x and this one will cancel. We'll be left with sine square x minus du. Now what happens because we have replaced u equal to cos x. Again we will apply the simple trigonometric identity and replace sine square x by 1 minus cos square x, and this is minus du. So this becomes integration of minus 1 minus u square du, which is the same as writing integration of u squared minus 1, because this is minus 1 and minus becomes plus, so it will be u squared minus 1 of du. This is a very simple integration problem now. So integration of u squared becomes u cubed by 3, and integration of u becomes, integration of 1 becomes u, and we add the integration constant of integration, which is c. Now we will just replace u by cos of x. So this is cos of cubed x by 3 minus cos of x plus c. Okay. Let's take another example. Integration of sine to the power 5 dx. Again we will replace u by cos of x, where du by dx is equal to minus sine of x, which means dx is equal to minus du by sine of x. Okay, now so this becomes now sine to the power, we can replace this by, sorry, for x here, sine to the power 4, sine to the power 5x, dx is replaced by minus du by sine of x. So this one will cancel with this. I am left with 4. Now sine to the power 4x can be written as sine square x whole square minus d by u. And as we know, sine square x is 1 minus cos square x whole square minus du. So we can take minus outside the integration sign, and now we can replace cos by this one by u. So this will become minus 1 by u square whole square and du. So this becomes minus, we expand this expression now, 1 minus 2u squared plus u to the power 4. Okay, and d. So if we replace this minus in all this, it will become 2u squared minus 1 minus u to the power 4 with respect to du. So it becomes a very simple integration problem now. Integration of 2u squared is 2u cubed by 3. Integration of 1 is u, and integration of u to the power 4 is u to the power 5 by 5. And we add the constant of integration. And now we just have to replace u by the expression that we have substituted, that is cos. So it is 2 cos cubed x by 3 minus cos of x minus cos of 5 power 5x upon 5 plus c. Okay. Let's take another example. So we have here now integration of tan of x dx, and as we know, we have no standard formula that we had for sin x cos x, integration of sin x cos x and so on. So tan x, how can we integrate tan x? So we just have to replace tan x by, as we know, tan x is sin x by cos x by dx. Okay, again we'll replace u is equal to cos x. So du by dx is equal to minus sin of x. So dx is equal to du by sin of x minus. Okay, now we know that we have replaced u by cos x, so this becomes sin of x by u, and dx is what? Minus du by sin of x. Okay, so sin of x and sin of x cancel. Again we get a very simple relation, minus 1 by u du, and as we know, integration of 1 by u is ln of absolute value of u plus c. So this becomes minus ln absolute value of cos x plus c. Okay, that is all for today's lecture. Thank you.